Okay, moving on to the Adept level for Chapter 8, Sections 1 and 2. We're continuing on with solving systems graphically, but if you look at the system here, it's just a little bit more complicated looking, but we're not going to really do anything new. So let's isolate y so we can express it in slope-intercept form. So this gives me, I'll just write it out again, 3x is equal to 4 minus 4y. Okay, so I have a minus 4y here, so I'm going to add 4y to both sides. That way it'll appear on the left as being positive, which means this 3x has got to go. It's positive, so I'm going to subtract 3x from both sides. This 4 is going to stay right there. So it looks as though the x term and the y term are switching, but they're not. Okay, I'm treating both sides the same. Okay, well, we're not quite done yet. We need to divide out the 4 here. There we go. So 4 over 4, well, that's just 1. So I get y equals, and this is not reducible, so that gives me negative 3/4 x. You could put the x in the numerator if you want, and positive 4 over 4 is 1, so you have to say plus 1. Okay. Well, this is not too difficult to graph. So this has a y-intercept of 1. So, and the slope is negative 3/4. So I'm going to go down 3 and write 4, down 3 and write 4. I'll do one more the other way, so I can go up 3 and left 4 instead. Okay, let's just trace my line in there quickly. And voila. Okay. All right, let's do it for the other one. This one looks kind of nasty. It actually looks like it's in general form, but technically it isn't because this x term here is negative. But I don't care about that. Let's just solve for y. So I have negative 2x. Plus y plus 10 equals 0. This is very simple to isolate. I'm going to subtract the 10 from both sides. I'm going to add 2x to both sides. And then I have positive y on the left, which is what I want. So this gives me y equals 2x minus 10. And there we go. So the y-intercept is negative 10. So that is here. And my slope is positive 2 over 1. So the line is going to travel up like so. Okay. I think by now you can actually probably see where our solution is because my pen actually touched it. There we go. Okay. So, at what point do these meet? Well, if you do your lines properly, right there. Okay, that is the only point that satisfies both the blue and the red line. Because after all, we're trying to find x and y values that work for both. So that occurs at x equals 4, y equals negative 2. So 4, negative 2. That's the solution to the system. Okay, so I'm just going to quickly solve the system one more time, just using the other method. So I'm going to plot the x and y intercepts and then just draw a line passing through those points. So for equation 1, so I'll do that one in blue, let's find the x-intercept. So the assumption is y is equal to 0. But this time, since when you substitute 0 into these equations, terms just disappear. So this negative 4y, there's no point in even writing it. So I just get 3x is equal to 4. So just to solve for x, both sides divide by 3. Uh-oh. X equals 4/3, or that's the same as 1 1/3. Okay. This illustrates why I'm not a huge fan of this method, because sometimes, okay, particularly with x-intercepts, when you have a slope that is a fraction, your x-intercept is not necessarily going to be a nice integer. Okay, if you look over here, it looks as though the x-intercept is 1, but just the way I drew the line. In fact, it doesn't have an x-intercept of 1. It's just to the right of it. It's actually at 1 and a bit, or to be more precise, 1 and 1/3. So if I'm using this technique and this is all I have to go by, I just kind of guess where that point is. So now I'm resorting to estimating where the points are on the graph, and if we're trying to find precisely where they cross over, well, you can see this technique is not necessarily the best way. But in the previous example from the previous video, we saw it didn't matter. So let's find the y-intercept. So that means x is equal to 0. So that means 3x. Well, that's just going to become 0. So I'm just going to solve 0 equals 4 minus 4y. And I'm going to add 4y to both sides. And then divide off 4 both sides. And I get exactly what I expected, y equals 1. And that was the y-intercept from before. So that's right here. Okay, but using this technique, now I'm trying to best guess where where this goes through. There we go. So sometimes certain methods work in situations better than others. All right, so now let's do the red line. For equation 2, let's find the x-intercept. So we're just setting y equal to 0. So this y term here, I'm not even going to bother writing it. So I get negative 2x plus 10 is equal to 0. And it doesn't matter which side of the equation you work with, but I'm going to add the 2x to both sides. That way the x term is positive. And then I'm going to divide both sides by 2, which gives me 5 is equal to x, or x is equal to 5. So my x-intercept is right here. Okay, and lastly the y-intercept. So x is equal to 0. That's pretty easy to solve. So this negative 2x term is just going to disappear. So the equation I'm solving is just y plus 10 is equal to 0, or y equals negative 10. So my y-intercept is down here. So let's just get the line in here as best we can. That color is correct, and hopefully it doesn't slip on me too much. Good enough. But we can see that the intersection is in the same spot. So x is 4, y is equal to negative 2. Now both methods gave the same result, but we could see here that this x-intercept is not a particularly nice number, so when it came to graphing, more or less had to guess where it was. So I would prefer this method. Verifying a solution. Once a system of equations is solved, it is often appropriate to check your answer. Show that x equals 8 and y equals negative 2 is the correct solution to the following system. So the nice thing about this is we don't have to solve anything. We're just going to verify that these two numbers are in fact the solution we're looking for. So for the first equation, what I'm going to do is create two columns, a left side and a right side. And we're just going to compare them, and hopefully things will work out. X minus 2y, so x minus 2y, where I replaced x with 8 and y with negative 2. The right side, well, that's just 12. Okay. Now, 8 minus 2 times negative 2, that is the same as 8 plus 4. And that right-hand side is still 12. And 8 plus 4 is 12. Does 12 equal 12? Sure hope so. So we've only verified so far that x equals 8 and y equals negative 2. That solves equation 1. But that's not enough to necessarily solve the system. those numbers have to work for equation 2. So let's do it one more time. I have left side, right side. Split them. 4x, so that's just 4 times 8. And 30 minus, now you got to be careful here, minus y. So 30 take away negative 2. So this is 32. When you're subtracting a negative, that's the same as just adding positive. Yay. 32 is equal to 32. So we have in fact verified that this solution does solve the system because it works for both equations.